You're welcome to yet another lecture series. So today we're going to be looking at chapter 3, lecture on structure and stereochemistry of alkanes. Alkanes fall under the main group of compounds or class of compounds known as hydrocarbons. Hydrocarbons are organic molecules that contain carbon and hydrogen only. And among these, we have alkanes, where all the carbon-carbon bonds are carbon single bonds. And then we have alkenes, in which we have at least one carbon-carbon double bond. And we have alkynes, in which we have at least one carbon-carbon triple bond. And we have aromatics, also known as arenes, which are a group of compounds that conform to some structural resemblance with benzenes. So benzene is the main member of this class. We're going to look at each of these functional groups in greater details. So alkanes are said to be saturated hydrocarbons just because all the carbon-carbon bonds are single bonds. Alkanes conform to a general formula CnH2n plus 2, which means if n is equal to 1, then we have a CH4, the first member of this group, which is methane. These are the most basic functional groups in organic chemistry. And again, I would remind you that this chapter is the foundational chapter for organic chemistry, with a lot of rules that would be applied to other functional groups that you should pay great attention to, especially when it comes to nomenclature. This class of compounds are basically unreactive. All the carbons are sp3 hybridized, and all the bond angles are 109.5 degrees. And this is the most comfortable angle for the carbon atom in organic compounds. They are found in everything from natural gases to petroleum. Smaller alkanes have low boiling points. And so we have most of them are gases. Lower molecular weight alkanes are gases. We have methane with a boiling point of a negative 160 degrees Celsius. We have the second member of this class is ethane with a negative 89 degrees Celsius boiling point. And we have propane, C3H8, with a negative 42 degrees Celsius boiling point. Now, although they are said to be non-reactive, they do undergo combustion and cracking reactions at very high temperature, in addition to free radical halogenation reactions in the presence of UV light and heat. They are the simplest and again the least reactive class of organic compounds. Now, being the first class of organic compounds, we're going to start up by looking at nomenclature of these compounds. And when it comes to naming these compounds, we're going to learn how to count like organic chemists, in which case we call 1, when a compound has only one carbon atom, the prefix is met. Again, when you talk to met here, we are looking at the good one. Please don't think about the bad one. When it has 2 carbon atoms, we're looking at et. 3 carbon atoms is prop. 4 carbon atoms is built, 5 carbon atoms is pent, and 6 is hex, and so on. Now for the class of compounds alkanes, because they end in A-N-E, the first member will add the A-N-E ending here, and so that is how we get methane. We have A-N-E here, we get ethane. A-N-E here, we get propane. A-N-E here, we get butane, and so on. So if you look at the molecular formula of these compounds, you will notice that each time a carbon is added, 2 hydrogen atoms are added to that. So remember, the general formula is CnH2n plus 2. So for any additional carbon atom, we are getting 2 more hydrogen atoms. Again, the first member of the class is methane. We have ethane, C2, propane with C3, butane, C4, pentane, C5, and so on. Now from C4 onwards, we start having some structural rearrangements of the carbon atoms. Like we have butane, which is 4 carbon atom, and we also have isobutane, which also has 4 carbon atom. We'll look at these structural differences in more details, but for starters, compounds that have the same molecular formula but only differ in their carbon skeletal arrangement are known as constitutional isomers. And we're going to look at this in greater depth. Alkanes typically again have low boiling points, and the lower class of alkanes are mostly gases. So when we look at butane, now we have 4 carbon atoms. These carbon atoms can be arranged in a straight chain, and which is the regular way that the molecule will occur. And so this regular way name is denoted by an N, which indicates normal butane. But then 3 of the carbon atoms could be in a straight line, and then one of them becomes a branch. And so that is a branch compound, and when we start looking at the nomenclature, we're going to understand how these branches are named. But here, each time we have something that looks like a V here, that gives us the iso group, and so this molecule is named isobutane. Again, molecules that have the same molecular formula but differ in their carbon connectivity are known as constitutional isomers. So with pentane, here we have 3 isomers of the compound. So we can have all 5 carbons in a straight chain, and that will be named N-pentane, or we can have 4 of them in a straight chain and one of them as a branch, and here we have isobutane. Now notice that we can count from left to right. It's 1, 2, 3, 4. We could also go from right to left in that counting mechanism. We're going to see that more in the nomenclature. So the branch could be on this carbon right here, and so we can have our other carbon there and these two structures will be the same. So there is no directional rule when it comes to looking at organic molecules. And then here we have another structure where 3 carbons are in a straight chain and 2 of them are branched. So we have a branch here and a branch there, and that is known as the neopentane. Now let's look at the branches here in greater depth. Now when we have the first class of compounds, we call them alkanes, and they have the ane ending. Now if they are short of one hydrogen atom, they are called alkyls. Alkyls. So alkyl groups are alkanes less one carbon atom. So here we have methane, CH4, but then CH3, one hydrogen atom less, is a methyl group. And so these names are the names we are going to use for the branches. Call them substituents. Substituents. We are going to name the substituents as alkyl groups. And so ethane less one hydrogen atom gives us the ethyl group. And propane less one hydrogen atom gives us the propyl group. And the propyl group can be in 2 forms, because the hydrogen atom that is reduced could come from the middle, and in that case we'll have what is known as the isopropyl. Again, notice the V shape at this end here, and so that gives us the isopropyl group. And we have other groups, the butyl group, and butyl group can give us 2 or 3 other structures. So we have the butyl group, in which all the carbons are in a straight line, and then we have the isobutyl group. Again, here the methyl group comes on carbon atom 2, and we again have that V-shaped structure at the end of the molecule. And again, there are 1, 2, 3, 4 carbon atoms, so it's an isobutyl group. Then this other one here, notice that the methyl group is not on carbon atom 2 here, it is right at this other end, and so the V shape is not coming out there. This is the part that connects to the main molecule, and so this group will see 3 and a methyl group right here on carbon 3, and known as a sec butyl group. And then when we have 3 methyl groups bonded to 1 carbon atom as a group, this group is known as the terbutyl group. Terbutyl group. So you have to know how to name these different substituents, as we are going to apply them in naming molecules. Now, looking at the iso group in greater detail, again, the V shape at the end of the molecule gives us that iso nomenclature, as you can see here in these pink bubbles. And so this is 3 carbons, and so that is a propyl, so it's isopropyl. Here we have 4 carbons, so it's isobutyl. And this is the isobutane. Remember, the butyl group means that it's a butane less 1 hydrogen atom. And here we have 5 carbon atoms with this shape at the end, and this is known as the isopentyl group. We also have multipliers that are used when we start having more of these branches linked to a parent chain, and we're going to use multipliers like di, tri, tetra to denote the number of groups that are attached to the main chain. The multipliers are not going to be used when we start alphabetizing groups, but iso will be considered in alphabetization. And it should be noted that the iso name for groups are common names. We're going to look at how to name these compounds systematically. And then here we have the neopentane, and so we have a neopentyl group when we get less one hydrogen atom. And this molecule right here is known as a neopentyl bromide. And the IUPAC name of this molecule, we can number the longest carbon chain from here, 1, 2, and 3. And we have, on position number 1, we have a bromine, and alkyl halogen substituents are going to be known as fluoro, chloro, bromo, iodo. And so this is 1 bromo. And on position number 2, we have 2 methyl groups attached to that, and so we have 2, 2. And since there are 2 methyl groups, we're going to use a multiplier di, methyl, in that nomenclature. And so that's how we get the name. Have to put them in alphabetical order. And so it's going to be 1 bromo, 2 dimethyl, and because the longest chain there is 3 carbon atom, that is a propane. So it's 1 bromo, 2 dimethyl propane. The branches have to be put in alphabetical order. And so bromo should come before methyl. So talking about the IUPAC system of naming compounds, IUPAC is the International Union of Pure and Applied Chemistry, and they have adopted a standard method that is used internationally for naming organic molecules. It uses the longest continuous carbon chain as the parent or the main group. The longest chain is numbered to give the location of other groups attached to the chain. Common names are kept or are still being used, but we're going to try to see how we can give these systematical names using the IUPAC methods. So we have methane, ethane, propane, butane, isobutane, pentane, and so on are going to be used. So in naming these compounds, we have some basic rules to follow. Rule number 1 is that we have to find the main chain. And the main chain again is the longest continuous chain of carbon atoms. And that uses the name of that chain as the base name, or I always call it the parent name of the compound. So if the longest carbon chain contains 3 carbon atoms, then that compound has a parent name of propane. If it contains 4 carbon atoms in the longest chain, then that parent name would be butane. Then the second rule will be for us to number the carbon atoms in the longest chain. We have to begin from the end of the chain that is closest to the branches or substituents. We have to number from the end that is closest to the substituents. The third rule is we have to name those groups that are attached to the main chain as alkyl group. Remember, when you are attached to the main chain running like that, if a methyl group is attached to the main chain, it's only going to have 3 hydrogens. So it cannot be methane. We're going to call it a methyl group. So we're going to name those substituents as alkyl groups. We're going to give the location of each alkyl group by the number from the main chain of carbon atoms to which that group is attached. So when 2 or more substituents are present, we're going to write them in alphabetical order. We're going to alphabetize all the substituents, regardless of their positions on the main chain. When 2 or more of the same alkyl groups are present in the molecule, we're going to use multipliers, di, tri, tetra, etc. to avoid repetition of the alkyl groups. And in rule number 5, the names of these compounds are going to be written as a single word. There will be no spaces. We're going to use commas to separate numbers. So if I had a 2, 3, 3, and if I have to write letter, I'm going to use a hyphen to separate the numbers from the letter. So that will be 2, 2, 3, and I have tri-methyl, for example. So that means there are 3 methyl groups. One of them is on position 2, 2 of them are on position 3. We have to have as many numbers in our names as we have substituents. So let's look at applying these rules. The first rule for us is to look for the longest continuous carbon chain of atom. And this will give us the best name of that prefix. Again, remember, we have to know how to count. 1 is met, 2 is et, 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 is sept, 8 is oct, 9 is non, and 10 is dec. And so we're going to have methane, propane, butane, pentane, hexane, and so on for those parent names. So right here we have a molecule. So we're going to try to name, to number, to look for the longest continuous chain of carbon atoms. And if we look at that, here in red we have our longest chain. And so we're going to try to number. So we've identified that longest chain in the molecule. And so we may check for substituents, and then we give that molecule a name. And so from here, if we count the carbon atoms, we're going to have carbon atom 1, 2, 3, 4, 5, and 6. And so since there are 6 carbon atoms in the longest chain, that molecule is going to be known as hexane. Now we have this other structure. Again, we're going to try to look for the longest chain. Again, remember, there is no direction when it comes to numbering. You're just trying to look for the longest continuous chain. And so in this case, this is the longest continuous chain. And again, it goes from 1, 2, 3, 4, 5, 6, and so we also have 6 carbon atoms, and so this is also a hexane. Did I have 6 or 7? Oh, I missed one. So it's 1, 2, 3, 4. I missed that one. 5, 6, and 7. So there are 7 carbon atoms here, and so this is a heptane. Now, if 2 different chains of equal length are present, we have to choose the one with the largest number of branches. If 2 different chains of equal length are present or possible, then we have to go with the one that has more branches. For example, we have this structure, and we can count from here 1, 2, 3, 4, 5, 6. And we can also see another one like this. We're going to now look for the chains. So this gives us 6 with 2 branches. This gives us 6 with just 1 branch. So we have 6 with 2 branches or 2 substituents, and we have 6 with just 1 substituent. The correct one will be the one that has more substituents. Hexane with 2 substituents, hexane with 1 substituent. 2 substituents is better. So work on this, practice, and put correct on the right longest chain, and you can practice some more with these structures as you try to give their complete names. Now we have to number the carbon atoms in the longest chain and begin at the end of the chain closest to the first branching point. And we number each carbon atom in that parent chain. So here we have the parent chain, and we're going to try to look at the end closest to the branches. And so we go put our numbers 1, 2, 3, 4, 5, 6, 7. So we get 7, and we get our first branch is found on carbon 3. We could also have numbered that compound the other way, where the first branch point will be found on carbon 4. But we want to give the first branching point the smallest number possible. And so that first branching point on carbon 3 is the best choice. Again, try to look at these 2 molecules down here and practice to identify which numbering system is right. Now we have to number the carbon atom in the longest chain, and if branching is equal distance away from both ends, then we have to now consider the second branch. We have to now consider the second branch, and we want to give the numbering closest to the second branching point. So for example, we have this molecule. We could have numbered it this way. Starting from here, we have 1, 2, 3, and we have a branching point on 3. If we number from the other end 1, 2, 3, we also have a branching point from position 3 right here. But then now we have to consider the second branching point. And so we have to number it in the direction that will give the second branching point the lowest number. And so we're not going to number it this way. Rather, the one that gives the second branching point the smallest number is the best choice. Now, when the same numbers are obtained in both directions, so the one that will come first alphabetically will be the one that gets the smallest number. So in this case here, on position number 3, we have a methyl group. And on position number 3, on the other direction, we have an ethyl group. And since ethyl comes before methyl, the numbering in blue, that gives the methyl group 3, is the right numbering. And so this molecule will be named 3-ethyl-5-methyl-heptane, and not the other way around. Now, these rules for nomenclature are very important. Each time you are naming a molecule, you have to try to make sure that you are putting these rules into practice. Each time you violate a rule, your name will be wrong. So we have to identify the number of substituents. Name the groups attached to the longest chain as alkyl groups and assign numbers to each substituent according to its point of attachment to the main chain. And so here we have this molecule. We have numbered it correctly, and we have 9 carbon atoms, which means the main chain is a nonane. And so we are going to look at the substituents. We have a substituent which is an ethyl group on position number 3. And so we have an ethyl group on position number 3. We have a methyl group on position number 4. And we have another methyl group on position number 7. And by so doing, we are not going to repeat methyl groups. So we're going to group these two together and use the multiplier di-methyl to write those. And we're going to write the numbers in increasing order. So it will be 4, 7, 4, 7 hyphen di-methyl. And since ethyl comes first, we'll have to put 3 hyphen ethyl and then hyphen 4, 7 dimethyl, and then the molecule is a nonane, so we have to gonna put nonane, and that's how we get the complete name for that structure. So 3-methyl, 3-ethyl, 4-methyl, 7-methyl, and we put those together to get our full name. So if two substituents are on the same carbon, we give those substituents the same number. Remember, you must have as many numbers as there are substituents. If you have 10 substituents that are all the same, you must have 10 numbers. So for example, we have this molecule. Again, we're going to have the chain. We number our chain. We look out for our substituents. We have C2 has a methyl group. C4 has a methyl group. And C4 also have an ethyl group. So we have to use 4 twice in that name. 2-methyl, 4-methyl, 4-ethyl. The 2 methyl groups, we're going to put them together because we cannot repeat the alkyl names. So there will be a 2, 4 dimethyl in that nomenclature. Again, we're going to be progressing with the rules. Those substituents have to be put in alphabetical orders. Okay? So if 2 or more identical substituents are present, we have to use multiplier prefixes, di, tri, tetra, etc. And remember, these prefixes are not used in alphabetizing. We do not consider them when we are putting these groups in alphabetical order. So if we have this molecule here, we have two methyl groups. We have it position 1, 2, 3, 4. So there is one on carbon 2 and there's one on carbon 4. So there is a 2,4 hyphen dimethylhexane. And on this other one, if we number the molecule correctly, we're going to have 1, 2, 3, 4, 5, 6, 7. And on carbon number 2, we have a methyl group, and on carbon number 5, we also have a methyl group and an ethyl group. Again, the names of these branches are put in alphabetical order. So 5-ethyl is written first, hyphen 2,5 hyphen dimethylheptane. That is how that molecule is named. And in the same way, we have these other molecules down here. We have 3 ethyl groups attached on carbon 3. We have 1, 2, 3, and we have 2 ethyl groups on carbon 3, and then 4, 5, 6, we have an ethyl group on carbon 6, and on carbon 7 we have a methyl group. And so we're going to do 3, 3, 6 triethyl, 3, 3, 6 triethyl hyphen 7 hyphen methyl, and the longest chain has 10 carbon atom, and so that molecule has the parent name as decane. Similarly, on here we have a 5-ethyl 2-methyl octane. A lot of rules to remember, but please, practice makes perfect. If you practice this, you should be good. Now, each time we write the name of the molecule, we're going to write the name as a single word. Again, we're going to use hyphens to separate numbers from letters, and we're going to use commas to separate numbers. So we're going to try to apply the rule. Here we have 6 carbon atoms, and so this will be a 3-methylhexane. Here we have the numbers. We have 2 methyl groups on position 4 and position 7. And we have an ethyl group on position 3. And so we're going to go with the ethyl first. So that will be 3-ethyl. Remember, we have to put a hyphen between the letters and the numbers. And we have to use commas between numbers. So 3-ethyl hyphen 4,7 hyphen dimethylnonane. And here we have another example, 4-ethyl 2,4 dimethylhexane. Remember, if you omit a hyphen, your name is wrong. If you omit a comma, your name is wrong. You must respect all the rules. I have a few examples here for you. Do this and you can check back with me to see if your answers are correct. So if we have complex substituents, here we've just been looking at ethyls and methyls as substituents. Substituents are not always going to be that easy. Complex alkyl substituents are occasionally encountered. And what happens when we encounter them? We have to name them as a molecule of their own. However, remember they are a branch, and so they must be named as alkyl groups. They will be named as alkyl groups. For example, we have this molecule. If we look at the longest chain here, we have that's the longest chain in red. We number that chain And on position 2, we have a methyl group. On position 3, we also have a methyl group. But on position 6, we have this entire group. So this group, we have to give it a complete name. And the carbon number 1 of that group is the carbon that is attached to the main chain. And so the carbon right off of the branch of the chain is given number 1. And then we have 2, and then we have 3. And so that is a 3 carbon chain. But if you look carefully, you can also notice the V shape that we have been looking at, the iso. And so this is an isobutyl group. That group is all known as an isobutyl. So you can name it as isobutyl, but isobutyl is a common name. If we have to name it systematically, it is going to be a propyl group, the longest chain, with a substituent on position 2. So it is a 2-methyl propyl. So it's 2-methyl propyl. That is the name, systematic name of that branch. And so we're going to name them as a whole molecule of their own. So we'll have the substituents. We have a complex one. So it's a 2-methyl propyl group. But again, like I indicated, it is also an isobutyl group. So the entire name of this molecule would be 2,3-dimethyl-6- in parentheses. Now we put the complex name 2-3-methyl-propyl decane as the name of the molecule. Now looking at more complex branches, again, remember carbon number 1 is the carbon that branches off the parent chain, so that the parent chain is here, and so that's carbon number 1. And we look for the longest chain. We can go from here 1, 2, 3. We can also go 1, 2, 3. Remember the rule. If there are 2 chains of the same length, we want the one that have more branches. And so if we go this direction, the chain has 1, 2 branches, and that is the better way to name it. And the longest chain is 3, and so that is a propyl, and we have an ethyl group on carbon 1, and we have a methyl group on carbon 2. So we have a 1-ethyl, 2-methyl propyl as the name of that group. Similarly here, again, we have the main group, the main molecule is this way, attached here, and so this carbon is carbon atom 1, have 1, 2, 3, 4, so that is a butyl group, and the butyl group on position number 1, we have 2 methyl groups, and so we have a 1,1,3 trimethyl butyl. Remember, it is a branch, so you cannot call it butane. It is a butyl group. On this other molecule, we have another one. Again, we could have done the same, gone this way to get 3, but that will only give us a single branch. So we have to go with the numbering that gives us more branches, and that will be the same as the previous one we had at the top. And this entire molecule right here would be named 3-ethyl. On position number 5, that is where we have that big group. And in that case, now we have to put that name in parentheses. 1 ethyl 2-methylpropyl nonane. And we have a cyclic alkane here, and the cycle has 8 carbon atoms, and so the parent chain is a cyclooctane. We name cyclic compounds as cyclo, and so that's a cyclooctane chain. And then we can name now this complex branch here with the first carbon branching off of the parent as carbon number 1, and we have a 4 carbon chain. And on position number 1 we have 2 methyl groups, so we're going to use 1 twice. And on position number 3 we have another methyl group, and so we have 1 1 3 tri, because there are 3 methyl groups, butyl for the 4 carbon chain. So it's 1 1 3 trimethyl butyl branch. And looking at the parent cyclic compound on position number 1, we have 2 methyl groups here. And so this is 1 1 dimethyl. Remember, we cannot combine these methyls here to this bigger branch because this is a molecule of its own. Now you try looking for the longest chain here, follow all the rules, and see how you can name this compound. We'll continue with cyclic compounds in the next lecture.